Hello students, welcome to my channel. My name is Darshan. I am your maths prof. So in last session we saw some questions, some non-calculator questions, paper 2 style questions based on HCF and LCM. Now in this session we'll see non-calculator paper 2 style of questions only, but from the most important topic of the chapter 1 and chapter 2 both, and that is indices. Okay, this is very important topic. This is why I've collected 4 worksheets instead of 3. So we'll be solving all 4 worksheets here in the session, and I would request you to take notebook and pen and start solving with me only. When you're solving with this same speed, then it will be a time when you'll solve by yourself without any help. Okay, so just keep practicing, and I know this topic is little bit, it requires more efforts, but once you are thorough with this topic, I think you'll be able to secure at least 4 to 5 marks in paper 2, and same 3 to 4 marks around in paper 4 easily, because every year you will find at least 2 questions from this topic. Okay, so let's start with the first worksheet of indices. Yes, so this is the first question. T raised to 21 divided by t raised to 7, we are supposed to simplify that. Now before solving the question, I would request go through the session, go through the explanation session of this topic indices. I have specified all the identities used for solving the indices questions. Here we are solving this first question, and for that I'm using the identity that if two bases are same in the division, then you subtract the power. So this is the first questions, and that will be 21 minus 7, so t to the power 14 is the answer. Similarly, in the B part of it, there is a u raised to 5 to the power 5, and we have this identity that a raised to n to the power m is always a to the power n times m. So power will be multiplied. So this will be u raised to 5 times 5, which is u raised to 25. Clear? Let's jump to the second question, and that is the same kind of question, x raised to 8 to the power 3. So we'll multiply the power, and it will become x to the power 8 into 3, which is x to the power 24. Now here in third question, there is a equation kind of question. Now in the equation kind of question, we are supposed to find the variable. Here the variable is x, and we are supposed to find the value of x. For that, in the equation kind of question, I have already told you that on the both side of the equation, I mean on left hand side as well as on right hand side of the equation, the base should be same, and if the base is not same, then you do the prime factorization of the base to make them same. Okay, here the bases are already same, it's t only. On left hand side also the base is t, and on right hand side also base is 3. So we can directly start solving this. For this I am using this identity that a raised to n into a raised to m, that is a raised to n plus m. So in multiplication, if the bases are same, then you can add the powers. So according to that, this will become t raised to x plus 2 is equal to t raised to 10. Now on both the sides of the equation there are only single terms, and both have the basis t. So this is why powers must also be same. So x to the x plus 2 is equal to 10. So x is equal to 10 minus 2, so x is equal to 8. So this is your answer, x is equal to 8. Fourth question, 3e whole to the power 0. Now we already know that from the indices identity that anything raised to 0 is always 1. Okay, so according to that identity, this is also 1. Here you see there's division and bases are same, so you will simply subtract the powers. So so this is 2 minus 3, which is w raised to minus 1. You can also write this answer, or you can further simplify it and make the power positive. For that you will have to write 1 upon w raised to minus 1 is 1 upon w raised to 1, which is 1 upon w only. So this is also correct answer and this is also correct answer, both are valid. If in the question they've specified that write the answer in positive powers, then only this will be the correct answer. This is incomplete. Clear? Okay, so next, now there's a second worksheet. See the first question. Okay, so we already have this identity that if it is a into b whole to the power m, then it is a raised to m into b raised to m. That means in multiplication, if there is a common power, then you can give them separate powers, and this is valid for division also, not in the addition or subtraction, but for multiplication and division. If there is a common power, you can separately give the power to each variable. So here that is a 3 raised to 3 into x square raised to 3 into y raised to 4 to the power 3. Now 3 raised to 3 is 3 into 3 into 3, which is 27. This is x raised to 2 into 3, which is x raised to 6. This is y raised to 4 into 3, which is y raised to 12. For those who couldn't understand this, I have used that identity that power will be multiplied. So here 2 into 3 is 6 and 4 into 3 is 12. Now I can just simply write it like this: 27 x raised to 6 y raised to 12 without the multiplication sign. So this is the answer for the first question. Let's jump to the second question. Here 2 and 5 are the coefficients. They'll be multiplied with each other because there's a multiplication sign here. So 2 times 5 is 10, and x raised to 2 into x raised to 5. In multiplication, if the bases are same, we add the powers. So there x to the power 2 plus 5, so which is 10 x to the power 7. Clear? Let's see the third question. Here the whole power 3 is given, so I can give them separate powers. So 4 raised to 3 into x raised to 3 into y square raised to 3. So this will become 4 raised to 3 is 4 times 4 times 4, which is 64, x cube as it is, and y raised to 2 to the power 3, which is y raised to 2 into 3. So I can write 64 x cube y raised to 6. This is the answer. Now see the fourth question. So here it is 8t to the power 8 divided by 4t to the power 4. I have written in this form, in fractional form. Now you can cut this. 4 ones are 4 and 4 twos are 8. So that is 2 into, now in division, if the bases are same, you can subtract the powers. So that's t to the power 8 minus 4, which is 2t to the power 4. This is the fourth question. Now fifth one, same kind of question, give them separate powers. So 5 raised to 3 into x raised to 4 to the power 3. 5 raised to 3 is 5 times 5 times 5, which is 125, into x raised to 4 into 3, because power will be multiplied. So that is x raised to 12. So your answer is 125 x raised to 12. Okay, here you see there is a common power, so you can give them separate powers. So it is 27 raised to 1 by 3 into x raised to 6 to the power 1 by 3. Now if you haven't watched that video where I have specifically given you the notes that there are two types of special questions in this indices topic. One is the equation kind, and another is when the power is in fraction. Okay, so in that case, if you haven't seen that video, just go and watch that video. It is given in the playlist only. But now here, those of you who have already watched that video, look at here, 27 raised to 1 by 3. So here the power is in fractions. So to solve that, I'll do the prime factorization of 27. So 27 can be prime factorized like this. It is divisible by 3, so 9, then divided by 3, so 3, 3, so 1. So 27 can be written as 3 to the power 3 and its power is 1 by 3. Now this is x into x raised to 6 into 1 by 3, which is nothing but 2 only. So this is 3 raised to 1 into x raised to 2, which is 3x square. So mind my words, whenever there is a power in fraction, do the prime factorization of base to solve it. See the seventh question now. In the multiplication, first we'll multiply the coefficients. So 2 into 3 is 6 into, now in multiplication with the same basis we add the powers. So x raised to 3 plus 2. So this is 6x raised to 5. This is the answer. Eighth question, this is equation kind of question. In equation kind of question, again I am repeating, both the sides of the equal to sign must have the same basis, and if the bases are not same, do the prime factorization to make the basis same. So here you see on the left hand side of the equal to sign the bases are 3, but on the right hand side of the equal to sign the base is 81, which is not 3. So to make them same, what I'll do, I'll prime factorize the 81. So 81 can be prime factorized like this, divided by 3 you will get 27, 27 divided by 3 you will get 9, 9 divided by 3 you will get 3, and 3 divided by 3 you will get 1. So this 3 raised to minus 2 into 3 raised to x is equal to 3 raised to 4. Now the bases are same. What I'll do, on the left hand side, because there is a multiplication and bases are same, you will add the powers. So that is 3 raised to minus 2 plus x is equal to 3 raised to 4. Now cut the bases because bases are same and only single term is there, so you can equate the powers. So minus 2 plus x is equal to 4, so x is equal to 6. So your answer is x is equal to 6. Clear? See the ninth question. This is a simple one. In multiplication, if the bases are same, you add the powers. So that's a raised to 3 plus 6. So that is a raised to 9. This kind of questions are also done already, that if there is a common power in multiplication, give them the separate powers. So 5 raised to 3, x raised to 3 into y square raised to 3. So this is 125 into x raised to 3 into y raised to 6. So your answer is 125 x cube y raised to 6. Clear? See the 10th question. So now, before giving them the separate powers, first thing what you are supposed to do, that make the power positive. So for that I have this one identity, that if some number has power negative, then to make the power positive you will reciprocate the base and do the power positive. Okay, remember this identity. Many students make this kind of mistake, that while changing the sign of the power from negative to positive, they don't reciprocate the base. Instead of that, they reciprocate the power. I have seen the students doing like this, a raised to minus n, and then to make the power positive, what do they do? A raised to positive 1 by n, which is completely wrong. Don't make this kind of mistake. This is very common mistake I see in many question papers. So first, to make the power positive, the power will become from negative to positive, but the base, which is 4 upon x, will be reciprocated as x by 4, and the power will become 2. Now you can give them separate powers. So that's x raised to 2 upon 4 raised to 2. Now 4 raised to 2 can be written as 16. So this is your answer, x square upon 16. Here a cube b raised to 7 upon a raised to 6 b raised to 2. I have written the division in fractional form, and now in division the same base, with the same base will subtract the powers. So this a raised to 3 minus 6 into b raised to 7 minus 2. So your answer must be a raised to minus 3 into b raised to 5, which can be written as a raised to minus 3 b raised to 5. This is also correct answer. Or in the exam, if they've specified that write the answers in positive powers or positive indices, then you are supposed to convert it like this. B raised to 5 will remain as it is, but this a raised to minus 3, it will go in denominator and become a raised to positive 3. If it is not specified, then this answer is also correct and this answer is also correct. I hope you are following this. Let's go further. This is the 12th question that says that so this is 5 into 2, both are coefficients, so let's multiply them first. So it will become 10, then a raised to 3 into a raised to 2. In multiplication, bases are same, add the power, so a raised to 3 plus 2. Similarly, c square and c raised to 7. Multiplication, same base, add the powers. So this is 10 a to the power 5 c to the power 9. This is your final answer. 13th one, common power is given. To simplify, we'll give them separate powers. So 3 raised to 3 w cube raised to 3. So 3 raised to 3 is 27 and cubes cube power 3 is 3. So that is 3 into 3 9. So w raised to 9. Power will be multiplied like this. Okay. That brings me to the third worksheet of the same topic, indices. See this. This is the equation kind of question. Here we are supposed to find the value of k. Again I'm saying, in equation both the sides on the of the equal to sign must have the same bases. If the bases are not same, do the prime factorization. So this 25 and 125 are not same. Let's prime factorize both of them. So 25 can be written as 25's prime factorization is just 5 raised to 2, right? And 125's prime factorization, so that is this 5 raised to 3. So this 25 can be written as 5 raised to 2 and 125 can be written as 5 raised to 3, but on the right hand side it is 125 raised to k. So 5 raised to 3 to the power k. Now power will be multiplied, so this 5 raised to 3k. Now on left and right hand side both have the same basis and single term, so just remove that base and you can directly equate the powers. So 2 is equal to 3k, so k is equal to 2 by 3. This is the answer. Sorry. Second question. This is simple. You can give them separate powers. So this x raised to 9 to the power 2 by 3. Now this power will be multiplied, but here in the case of 27, if the power is in fraction, do the prime factorization of base. So this 27 can be prime factorized as 3 raised to 3. So you can write 3 raised to 3 is power 2 by 3 into x raised to 9 into 2 by 3, which is 6 only. So now this 3 got cut, so 3 raised to 2 into x raised to 6, which is 9x raised to 6. Okay, third question. The power is in decimal, so instead of writing in decimal, write it in the fraction. So the 64 to the power 1 by 2, and I'm already giving them the separate powers. So 64 raised to 1 by 2 into x raised to 4 to the power 1 by 2 into 4, and this x raised to minus 2 will remain as it is right now. Now 64 power 1 by 2, power is in fraction, do the prime factorization of base 64. 64 can be prime factorized like this, divided by 2 16, divided by 2 8, divided by 2 4, 2 and 1. So this 2 raised to 6 only. So 2 raised to 6 power 1 by 2, x raised to 4 into half, which is x raised to 2 into 4 into x raised to minus 2. Now the 6 times 1 by 2, power will be multiplied. So 6 times 1 by 2 is 3. So this is 2 raised to 3 and this is 4. Now you see in multiplication with the same basis, we can add the powers. So 2 plus minus 2. 2 raised to 3 is 8 into 4 into x raised to 0. 2 plus minus 2 is 0. Anything raised to 0 is 1. So this 8 into 4 is 32. That's all. 32 into 1 is 32. This is the answer. Fourth question, equation kind of question. Left hand side the base is 2, but right hand side it's base 4. This is 4 raised to p. So if the bases are not same in the equation, do the prime factorization. On left hand side the base is already prime, so you don't need to do that. On right hand side it is 4, so 4 can be prime factorized as 2 raised to 2. So on left hand side it is 2 raised to 3, and right hand side it is 2 raised to 2 to the power p. Now power will be multiplied, so 2 raised to 2p. On both sides the bases are same and there are only single term on each side, so you can remove that base and directly equate the powers. 3 is equals to 2p, so p became 3 by 2. So your answer is 3 by 2 here. See the fifth question, again equation kind of question, but bases are not same. On left hand side it is 5 raised to n, and 5 is already a prime number, no need to do the prime factorization. But on right hand side it is 125, which can be prime factorized like this. This is divisible by 5 and again 5 and again 5, so it's 5 raised to 3. Now on left hand side if you see, the base is in the numerators, and on right hand side it is in denominator. We will have to keep them on the same level. So on left hand side, because it's in numerator, let's put this right side also in the numerator, and whenever you are doing the reciprocal you will change the sign of the power. So power right now it is 3, so it will change to minus 3 if I put it in the numerator. So that is 5 raised to minus 3. Now remove the bases and directly equate the power. So n is equal to minus 3. This is the answer. If you will follow this note, I'll guarantee you that you will not make any mistake. You might find this method little bit lengthier, but it will keep the thinking uniform, so that whenever you see any equation kind of question in indices, you can definitely say that this is the method I'll have to follow. Maybe one or two steps will be extra, but definitely you'll get the correct answer, you'll not make mistakes. Same with the power which is in fraction. There might be other methods where you can get the answer quickly, but the chances of making mistake will be higher in that case. So just follow this thing. It might take 2 steps extra, but definitely it will give you perfect answer. Yeah. So see the sixth question. First step, make the power positive. The power is in negative 1 by 3, so it will become positive 1 by 3. Mark my word, power will not reciprocate, it will just become from negative to positive or positive to negative, but the base will be reciprocated. So here the base is 64 upon m cube, so it will become m cube upon 64, and the power will be positive 1 by 3. Now you can give them separate powers, so m cube to the power 1 by 3, but this 64 to the power 1 by 3. Now again my same answer, whenever the power is in fraction, do the prime factorization of base. Here m raised to 3 into 1 by 3 will become m raised to 1, but the 64 can be prime factorized as, it is divisible by 2, then again 2, then again 2, 2, 2 and 2, so it is 2 raised to 6 to the power 1 by 3. So this can be written as m raised to 1, which is m only, divided by 2 raised to 6 into 1 by 3, which is 2. So 2 raised to 2, which is m upon 4. Clear? See the seventh question. Equation kind of question. Both the sides should have same base. On left hand side it is 2 raised to p, and it is already prime, so it's fine. But on right hand side it is 8 raised to 4. To make the bases same, I'll do the prime factorization of base. So 8 will become 2 raised to 3 after prime factorizing, and now this is 2 raised to p is equal to 1 upon 2 to the power 12, because power will be multiplied. But on the left hand side of the equation, the 2 is in the numerator, so on right hand side also I'll have to push it into the numerator. For doing that I'll have to reciprocate the base, and for reciprocation I'll have to make the change in the sign of the power. So right now power is positive 12, it will become negative 12. Okay, now it's clear, both the sides have the single term and same base. Remove the base, directly equate the power, so you'll get p is equal to minus 12. Clear? See the eighth question, equation kind of, but bases are luckily same, so you don't need to do the prime factorization. The base is already in x. X is not even a number, so no need to do the prime factorization either. So now you see it is a cube root. Cube root is nothing but the power 1 by 3. I have already specified this thing in the explanation session. If you haven't watched it, go and watch it. It's very useful. And let me remind you that square root is also written as power 1 by 2. Cube root is also written as power 1 by 3. Similarly, any nth root is written as power 1 by n. So don't forget these identities. They are very useful to solve any kind of question in indices. So now let's convert this cube root as the power 1 by 3. So it's 1 by x to the power 1 by 3's power 4 is equal to x to the power m. Now power will be multiplied, so 1 by x raised to 4 by 3 is equal to x raised to m. Now on right hand side the x is in numerator, on left hand side it is in denominator. To shift it to the numerator, I'll reciprocate it, and in the reciprocation the power will become negative. Don't reciprocate the power. Again I am reminding you, don't reciprocate the power. So this is x raised to minus 4 by 3, the power became negative, is equal to x raised to m. Now both sides have single term and the bases are same, so directly equate the power. M is equal to minus 4 by 3. So this is your answer. Clear? See the ninth question. The whole fraction raised to power negative 2. First step, to make it a positive power, reciprocate the base, so it will become 18 into t to the power 6 into w to the power 10, which was in the denominator. Now it became in the numerator, and the numerator became denominator, so it is 9 into t to the power 4 into w raised to 9 whole to the power 2. Now first you simplify what is inside the bracket, because according to the board mass, bracket is simplified first and then you go to the off, because power is considered in the off. It's a power 2 of this whole bracket. So first you solve the bracket and then go to off according to board mass. So this 9 ones are 9 and 9 twos are 18. And if you see the t raised to 6 in the numerator and t raised to 4 in the denominator, so in division we subtract the powers of the same bases, so it will become t to the power 6 minus 4. Similarly, w to the power 10 minus 9. This is inside the bracket and there is power 2 outside the bracket for the whole bracket. So this is 2 into t to the power 2 into w to the power 1. Now if because there is the whole power in the multiplication and division, you can give the separate powers to each variable. So this is 2 raised to 2 into t square raised to 2 into w raised to 1 to the power 2. So that's 4 t raised to 4 w raised to 2. This is the final answer. Okay, this brings us to the fourth and the last worksheet of this topic, indices. See the first question. It's already in equation kind of question. Okay, on left hand side the bases are 2, but on right hand side it is 32. So to make the bases same, I'll prime factorize the 32. So it will be 16 divided by 2 8 divided by 2 4 2 and 1. So this on left hand side, because the bases are same and there is a division, you will subtract the power. So that is 2 raised to 12 minus k by 2 is equal to 32, can be written as 2 raised to 5. Now on both the sides single term is there and bases are same, remove the bases, directly equate the powers. So 12 minus k by 2 is equal to 5. Here I want to make k as a subject because I want to find k. So first this minus k by 2 will shift here and become plus k by 2, and this 5 will shift here and become minus 5. Okay, so this 12 minus 5 is equal to positive k by 2. 12 minus 5 is 7, and that is equals to k upon 2. Now to make k as a subject, this 2 which is in division, it will go in multiplication with 7. So k will become 7 times 2. So k is 14. See the second question. First step, make the power positive, which is right now in negative with minus 1 by 3. To make it positive, don't reciprocate the power, but reciprocate the base. So it will be 64 into y raised to 3, which is in denom. Now it becomes numerator, and 27 into x raised to 12, which became denominator, power 1 by 3. Now before giving them the separate power, first solve what is inside the bracket, because in the board mass bracket becomes first priority. But here inside the bracket there aren't any terms which can be simplified. 64 and 27, you cannot cut them, and x and y both are different bases, so you cannot subtract the powers also. So now you can directly give them separate powers because it's already simplified form inside the bracket. So after giving them separate powers, now what I can do, the 64 and 27 both have the fractional power. Same thinking, in fractional power, do the prime factorization of base. So this 32 to 16 to 8 to 4 to 2 and to 1. It is 2 raised to 3 and 2 raised to 6, and 27 is 3 9 3 3 and 3 1. So 27 is 3 raised to 3. So 2 raised to 6 power 1 by 3 into, now y raised to 3 into 1 by 3, because power will be multiplied. 3 times 1 by 3 is 1 only. So that's y raised to 1. And denominator, it is 27, which is 3 raised to 3, which we have already done. Its power 1 by 3. And 12 times 1 by 3, power is multiplied. So x raised to 12 times 1 by 3 is 4. So now 6 times 1 by 3 is 2. So that's 2 raised to 2. Y raised to 1 is y upon 3 raised to 3 into 1 by 3 is power 1 to x raised to 4. So that's 4y upon 3x raised to 4. This is the final answer. Clear? See the third question. Equation type of question. We want to find the value of q. Both the sides must have same bases. If the bases are not same, do the prime factorization to make them same. 3 is already prime. 27, let's do the prime factorization of 27, which is 3 raised to 3, and 81, which is 3 raised to 4. By the way, you don't need to show this prime factorization in the method. You can do this in the rough also, because it is not the part of the method. This method is made by me just to make sure that every student follows the uniform path and they get the same answer without any problem. So this 3 raised to minus q as it is, and 27 can be written as 1 upon 3 raised to 3, and this is 3 raised to 4. 81 is 3 raised to 4. Now in division we subtract the powers. So this is 3 raised to minus q minus 3. Now many students will ask me where this 1 went, because 3 raised to minus q into 1 is 3 raised to minus q only, because whenever you are multiplying anything with 1, the number remains as it is. So this whole numerator will become 3 raised to minus q only. So that 3 raised to minus q divided by 3 raised to 3. So now in the division with the same base, we subtract the powers. On right hand side remain 3 raised to 4 only. On both the sides same basis, just powers are different, and you can directly equate the powers. So like this. Now to make the q subject, this minus q will go here and become positive q, and this 4 will go here and it will be minus 4. So now this minus 3 minus 4 is equal to positive q. So q is equal to minus 7. This is the answer. Next question. First step, make the power positive by reciprocating the base. So this 25 into y square upon 64 into x raised to 6 whole to the power positive 1 by 2. Now before giving them separate powers, if you can simplify anything inside the bracket, do it first, because in board mass bracket comes first as your priority. But here in this case, inside the bracket you cannot change anything, you cannot simplify anything, because 25 and 64 cannot cut with each other, as well as in y square and x raised to 6 you cannot subtract the powers because the bases are different. So we don't have any choice, just give them separate powers. So y square raised to 1 by 2 upon 64 to the power 1 by 2 into x raised to 6 to the power 1 by 2. Now 25 raised to 1 by 2, 1 by 2 is fraction, do the prime factorization of base. 25's prime factorization is 5 square, and 64's prime factorization we just did in previous pages, but if you haven't followed, just focus here. I'm doing it again. So 2 raised to 2, 2 times 2. So this 25 can be written as 5 raised to 2 to the power 1 by 2, because it's 25 raised to 1 by 2. Y raised to 2 times 1 by 2 is y raised to 1. 64 is 2 raised to 6, power 1 by 2 as it is. And x to the power 6 into 1 by 2 is x raised to 3. Now 5 raised to 2 times 1 by 2 is 5 raised to 1. Y raised to 1 is y only. 2 raised to 6 into 1 by 2 is 2 raised to 3, and x raised to 3 also. So this is 5y upon 2 raised to 3 is 8, so this is 8x cubed. This is the answer. Question 5 now. Equation kind of question. Both the sides must have same bases. If the bases are not same, make them same by doing prime factorization. 2 is already prime. 16 and 4 both must be prime factorized. Now I'm not doing anything. 4 you can already do that. 2 raised to 2 is 4, and this 16 is 2 raised to 4 only. Okay, you can also check by doing prime factorization by yourself. Now 2 raised to 2 times k by 3, so that 2 will be multiplied k plus 3, so 2 will be multiplied with k also, as well as 2 will be multiplied with 3 also. So that's 2 raised to 2k plus 6 is equal to, here on right hand side in the multiplication, because the bases are same, you will add the powers. So now both sides have same bases, remove the bases and directly equate the powers. So 2k plus 6 is equal to 4 plus k. Make the k as your subject of the equation, so this k will go here and become minus k, and the 6 will go here and become minus 6. So 2k minus k is equal to 4 minus 6. 2k minus k is k only, 4 minus 6 is minus 2. So your answer is k is equals to minus 2. Yeah, next is a round off, which we'll cover in the next session. So that was it. I know the video was little bit longer, but I would suggest whenever I am posting the video of solving the questions, I would request all of you to bring the notebook and pen with it, and keep the screen in front of you, start solving the question with me only. It will be time saving for you. You don't it's a math. You don't just watch the questions and you can learn. It's about practicing. So always whenever I'm posting any video which is based on the question solving, bring your notebook and start solving. Okay, keep practicing, students. Till then, just keep liking and subscribing the channel. It gives me motivation. Okay, thank you.